Buckle up, chuds, cause class is in session. I'm about to show you how you can get set up to print advanced engineering filaments for as low as $300, taxes evaded. And maybe finally you can get past that useless, colorful plastic garbage phase of 3D printing and ascend to functional parts that won't crumple under a hairdryer level of 3D printing. And maybe women on the internet will finally give you that validation that you so crave. I'm joking, of course. There are no women on the internet.
So actually, as far as I don't really know. I don't know how many women there are 3D printing.
Anyways, disclaimer. There is no creation of firearms in this video, nor am I teaching anyone how to create any firearms. I do not sell any firearms. I do not sell any firearms parts. And anyone who decides to use this knowledge to commit crime, I will personally call an ATF hit squad on you. Internet soy jack lookalikes will have you believe that filaments like carbon fiber nylon are specialist engineering filaments, not for normies like you and me who don't own a used car worth of 3D printing equipment.
This Pantheon HS3 is so overbuilt specifically because it's meant to print CF nylon at high speed. You need a powerful drive motor to force the filament in, fire-breathing hot end to get it out, and a powerful gantry just to whip all that around.
But honestly, I wouldn't take advice from a guy who has layer lines looking like that. But before I get ahead of myself, let me schizo rant a little bit about PLA. So PLA, for those of you who are uninitiated, it is the most common type of 3D printing filament you will encounter, and it is also the most toxic. And I might hear you in the back over there, blah blah blah, it's for prototyping. If you are using it for prototyping, I fully understand. I am not talking to you. I'm talking to the people who are creating functional parts in PLA. PLA will fold in a hot car. PLA will lose in a 1v1 with a hairdryer. PLA is the ramen noodle of filaments, meaning it will go flaccid in a hot bowl of water. You do not want anything that will take heat and impact and make it out of PLA. Meanwhile, fiber-filled filaments like glass fiber and carbon fiber nylon has the tensile strength of aluminum and can withstand temperatures of up to 190 degrees Celsius without warping. Most people think that nylon is an extremely unapproachable filament type due to its high hydroscopicness and warping and all this, and I'm here to tell you that it's honestly not that complicated. All you have to do is literally follow the instructions on the label and you will be able to print it. So in the beginning, there were two genders, Prusa and bamboo. But which way, Western man? Since we all know that a $1,000 printer should be able to print some of these advanced filaments, I'm here to talk about what is the minimum viable setup for actually molding CF nylon into a shape that you desire.
Like, if you're a broke boy, just say so.
Also, I am in no way saying that this is the most optimal or best setup for printing carbon fiber nylon. I am well aware that it is extremely scuffed, but I am here to talk about what is the minimum requirement for printing this filament. And I know this because I've printed carbon fiber nylon on an old Ender 3 V2 Neo, which was released in 2022. So the first thing you need is a printer that can heat up to 280 degrees Celsius. And despite Creality Ender printers advertising to only be able to heat up to 260 degrees Celsius, it can actually heat up to 280 degrees Celsius. I know this because I've done it. And I'm Fahrenheit bros, for a second, shut up. No one cares that you use Fahrenheit. Everyone who does science uses Celsius or Kelvin, so shut the fuck up. The next thing you're gonna need is an enclosure of some sort to keep the heat in the print, because without the heat, the nylon will absorb water and it will warp and all this stuff, so you need a heated enclosure. Just buy a $30 Mylar coated enclosure from Amazon for $30. The third thing you need is going to be a filament dryer, because as I said before, nylon is extremely hydroscopic, so you gotta keep the filament heated and dry. And you can get one of these for like, I think like 40 USD on Amazon. And the last thing you need is going to be some kind of hardened nozzle, because the carbon fiber will absolutely murk any kind of brass nozzle that you have. So just buy like the cheapest steel nozzle you can off Amazon, and preferably 0.6 millimeters or larger, because the fibers tend to clog nozzles. So with a grand total of $300 USD, you too can print carbon fiber nylon, and it's not complicated. I'm going to explain how to do it in a second. Although I just said that you can use an ender to print carbon fiber nylon, I would not recommend it, because in this day and age, there are printers that can do so much more and are so much more efficient and easier to use for beginners that I would just opt for a medium tier printer and just not have to, mess with it. I don't want to see anyone manually leveling their beds in current year 2025. Also, I freaking hate bed slingers. Bed slingers are the jankiest pieces of shit ever. Friendship ended with bed slingers. All you Creality fanboys can fucking cry me a river. My new best friend is Core XY. Core XY is just so much more goated, so much more stable. You're not flinging your print back and forth at 1,000,000,500 millimeters per second travel speed, okay? So shut the fuck up, just get a Core XY. If you're gonna spend money on printers, I wouldn't even recommend an Ender 3. Typically, when discussing nylon filaments, you'll usually encounter PA6 and PA12 nylon filaments. All you really need to know is PA6 is cheaper but less stiff, and PA12 is more expensive and more stiff, but also more brittle and prone to cracking. Luckily for us, a creator more intelligent and successful than myself has done rigorous strength testing to determine that out of all the nylon filaments, PA612CF is the best for certain applications, that being HT. I can't really say his full name in this video. I'm sure you understand why. Surprisingly, glass fiber nylon of horse reproductive juice fame performed the worst out of the nylon family, even worse than PLA Pro, so I would just skip that altogether. I myself have only printed PA6CF because I use it for night vision parts and thermal accessories, so the stiffness is not a critical problem for me. So if you have to choose a filament, go with PA612CF. That's a lot of letters and numbers. Back to other T97. So mashallah, we've come to the part of the video where I actually teach you how to squirt the carbon fiber nylon, and God willing, you follow these steps, you will be able to print carbon fiber nylon. It is not complicated. As I said a million bajillion times in this video, nylon is extremely hydroscopic, so you're gonna have to dry that filament before you print it, unless it's fresh out of the package. If it's fresh out of the package, you could just slap it on the printer, but do keep it in a filament dry box. So the steps are as follow. 1. Dry your filament. 2. Put your printer in the enclosure. 3. Replace the nozzle with a hardened nozzle, preferably 0.6 millimeters or bigger. 4. Level your bed. Step 5. Most underrated step on this list. Glue stick. It doesn't have to be fancy. You don't need that freaking nanopolymer garbage. Just get a glue stick from the dollar store and smear it on your print bed, and you won't have to deal with your print lifting mid-print. 6. Feed the filament from your dry box into the nozzle. 7. Slice your print with these print settings. This is what's worked for me. If that doesn't work, slower the better. And nylon is extremely goopy, so you may need supports, or you may need to tweak your slice or orientation in some kind of way, but this is what's worked for me. So 8. Pray to the machine god. 9. Hit print. Important, pay attention. Jingle jangle, backroom, skibbity toilet, jingle jangle, pay attention. Your prints will come out extremely dry and brittle because, well, you dried your filament and kept it hot for the whole time. So you gotta give it some time to absorb some moisture before you can actually start using it forcefully. Congrats, if you followed all these steps, you should have a baby Grogu or baby Groot planter that should be able to withstand a stupid amount of impact and heat. At least a lot more than your typical colored PLA spaghetti ones. Again, if you are having problems, remember to go slow on the print. Anyways, if watching this video sent the feds to your house, click like and subscribe. Special thanks to Cold Harbor Supply for partnering with my channel. If you guys are interested in night vision, thermals, or more, check out my link in description, link in pinned comment. Use my code T97thought-5 for 5% off your next purchase.